f over g, or f divided by g of x, is just defined as f of x over g of x. So in this case, that just looks like x minus 5 over x squared minus 1. And from there, we just basically need to make sure that it's in lowest terms. So we need to try to factor the numerator and denominator and see if we can get anything to cancel. So this numerator cannot be factored, but the denominator can. It's a difference of squares. Factors is x plus 1 times x minus 1, but nothing cancels. And so this is in lowest terms. And so either one of these two options would be a sufficient answer. I'll just go ahead and box in this last one here as our equation for f over g of x. And now our domain is going to depend on a couple things. We need to look at the domains of f and g by themselves, figure out where those overlap, and that's kind of our starting point. So if we have already found the domain of f plus g, f minus g, and f times g, then our starting point is the same as those domains. Now we might have some additional restrictions once we introduce this division. So to get that starting point, again, we look at the domain of f, which is all real numbers. We don't have any restrictions there. We can plug in whatever we want for x, and same with the domain of g. And so those domains would overlap for all real numbers. So our starting point is all real numbers. Now we have to look at the fact that we just introduced division, or a fraction, into our problem here by doing this operation. And so now we do have a denominator that has some variables in it. And so I can't plug anything in for x that would make that denominator 0, because dividing by 0 is undefined. And so we want to take our denominator, and I'll go ahead and take it in the factored form, and set it equal to 0. Just solve that equation. Those solutions will be the values that I have to leave out of the domain. And so if I take each of these factors and set them equal to 0, I get solutions of x equals -1 and x equals +1. So those are the only two numbers that we're not allowed to plug in. So there's a couple different ways to write that. Probably the easiest way is to say that the domain is a set of all x, so it uses these braces, such that is how we would read that bar. So it's a set of all x such that x does not equal -1 or 1. So the understood implication there is that x is a real number and x does not equal these two values. As an interval, the way that we would write that, I'll go ahead and jot that down here. We'd go from -infinity to -1, because that's the lesser of the two numbers. And to show that we're leaving it out, we would use parentheses. And then I'd have to pick right back up. So this union is just saying that we're basically joining these two intervals. Start right back up again at -1 and go to 1 and leave out the 1. And then start right back up again at the 1 and go to infinity. So either one of those is a valid option for the format of the domain.